Very good afternoon. My name is Bhavesh Desai. So this is my new channel, Benzene Chemistry. In this channel, particularly we will discuss about the GSET exam, GAT exam, NET exam, and TIFR exam. So recently I qualified the Gujarat State eligibility test for the assistant professor, and now I am preparing for the NET exam. Okay. So in this channel, we'll cover the topics of each of the competitive exam, different topics like pericyclic reaction, oxidation, reduction reaction. So in the today's lecture, we'll discuss about the pericyclic reaction because much higher weightage of pericyclic reaction in the competitive exam. So basically, the pericyclic reaction is a concerted reaction. What do we mean by the concerted reaction? Concerted reaction means simultaneous bond breaking and bond forming is called the concerted reaction. And like I said, this is concerted reaction, so no intermediate is involved in this reaction because this reaction occurred in one step only. Okay, this is not the multi-step reaction, and no transition state is involved. This reaction is occurred through the transition state. No intermediate like carbocation and carbon ion is involved in this reaction. And this reaction generally not affected by the solvent. And this reaction proceeds by heat or photochemical condition. Okay. Now we will discuss about the types of the pericyclic reaction. So there are three types of the pericyclic reaction. One is the electrocyclic reaction, second is the cycloaddition reaction, and third is the sigma-tropic reaction. So we'll first cover the electrocyclic reaction, and then in the next lecture we'll cover the cycloaddition and sigma-tropic reaction. Okay, so let us start with the electrocyclic reaction. Okay. So now we will discuss about the electrocyclic reaction. Okay, what is electrocyclic reaction? Electron movement in cyclic manner. Electron movement in the cyclic manner. Okay. And there are two types of electrocyclic reaction. One is the ring opening reaction, and second is the ring closing reaction. Ring closing reaction. And only one molecule participate into the electrocyclic reaction. Okay, either molecule undergoing ring opening or either molecule undergoing the ring closing reaction. Okay, what you have to understand, you just understand the which reaction, which system undergoing in which condition, heat condition, heating condition or photochemical condition, and via which rotation, on rotation or dis rotation. Okay, that you have to understand. Okay, so you just understand one table. Okay, and you will solve majority of the electrocyclic reaction questions. Okay, so here the system condition like heat and photochemical condition. Okay, because in both the condition different product is formed, so you have to understand which system undergoing electrocyclic reaction in which condition, photochemical or heat condition, because different product is formed. Okay, condition and the stereochemistry. This is a very important aspect of the electrocyclic reaction, stereochemistry. Okay, so there are basically two systems which is undergoing the electrocyclic reaction. One is the 4n pi system and second is the 4n plus 2 pi system. 4n plus 2 pi electron system. Okay. So in the heating condition, cone rotatory motion is happen. Okay, what is cone rotatory? I will tell you. Okay. And in the con rotatory motion, the stereochemistry is changed. Okay, and in the photochemical condition, 4 and pi system also undergoing the disrotatory motion. I will tell you what is con rotatory and disrotatory. Just I summarize all this stuff into one table. Okay, so and in the disrotatory condition, no change in the stereochemistry. Okay, you have to memorize only one system. Then you automatically memorize the second system, because second system is just opposite to the first system. Okay, so like I would say, the in the photochemical condition, the reactant undergoing bond rotation. So in the 4n plus 2 pi system, in heating condition, reactant undergoing disrotatory motion, and in the photochemical reaction, in the 4n pi disrotatory in the photochemical reaction, and 4n plus 2 pi system, in the photochemical reaction, con rotation both occur. Okay, and like I would say, in the disrotatory, no change in the stereochemistry, and in the con rotatory, change in the stereochemistry. Okay, just wait for a minute. Just I see the whether video is filming or not. So video is filming. 6 minutes are 6 minutes were gone. Okay, so you just have to memorize this table. This is very important table. You just memorize one system, and second system is just opposite to the one system. Okay, let us understand with the example. Okay, so let us take the example of cyclobutane, so you better understand the concept. Okay, so I have to take the cyclobutane example like this. This is cyclobutane. Okay, so first I'll take the heating condition. Okay, so what you have to do, you just draw the molecular orbital at the end of the carbon. There are 4 carbons, 1, 2, 3, 4. Okay, you should know the basics of orbital diagrams. Okay, so in the cyclobutane, psi 1 is a HOMO, psi 2 is a HOMO. There are 4 wave functions which are possible for the cyclobutane. Okay, just I summarize the wave function. This is psi 1, this is psi 2, this is psi 3, and this is psi 4. Okay, so how many electrons are present in the cyclobutane? There are 4 electrons, because 2 pi bonds are present. So here the 4 electrons are present. So this is HOMO, highest occupied molecular orbital, and this is LUMO. Okay, so you have to just memorize what are the signs of the wave functions. Okay, so in the first wave function, no node is present, so all the p orbital having same sign. Okay, in the second wave function, there is one node, so here the sign is changed because one node is present. And in the LUMO case, psi 3 case, there are 2 nodes are present, so here the sign is changed, here sign is similar, and here also sign is changed, and here the psi 4. So in the psi 4 case, there are 3 nodes are present, so all the p orbital are in a different sign. Okay, so you take the HOMO case. Okay, so in the cycloaddition, in the electrocyclication, you just take the HOMO of the wave function. Okay, so you just draw the and p orbital, the p orbital which are present at the end carbon, 1 and 4th carbon. Okay, so here the psi 2, the and p orbital having the different signs. Okay, you have to memorize in this way the odd wave function having similar sign in similar sign in the end, similar sign at the end, okay. And even wave function, you clearly see that the even wave function having different sign at the end of the carbon, different sign at the end of the carbon, okay. So you just memorize this, so you don't have to draw all the wave function which are possible for the cyclobutane or any other system. You just memorize this, odd wave function and even wave function, and which is homo and which is coho, okay. You just have to memorize this, okay. So okay, now we will look into what is con-rotatory and what is dis-rotatory. So first of all, you have to identify the system, whether it is 4n pi or 4n plus 2 pi. So this is 4n pi system because there are 4 electrons are present in this system, 4 pi electrons, okay. So like I was saying in previously in the table, the 4n pi system in the heating condition always con-rotatory motion, okay. What is con-rotatory motion? So con-rotatory basically, con-rotatory means in same direction, okay, whether it is clockwise or anti-clockwise, okay. So basically same sign of the wave function are combined to form the bond, okay. So basically these wave functions are rotate in this direction, okay. So we have to take the sign too, so sign is changed, okay. So basically the con-rotatory motion was occurred in this reaction. Just a minute, I made some mistake, okay. I write the p orbital like this. You have to better understand the concept. Wait a minute. Okay. Plus minus and minus plus. Okay, like I was saying, the even wave function having different signs. Okay. So same sign are combined together and form the bond. Okay. So this p orbital rotate in the clockwise direction, okay. So this p orbital have to rotate also in the clockwise direction, then only these two signs are combined and form the bond, okay. So in the con-rotatory clockwise rotation of p orbital, so same signs are same p orbital, same sign of the p orbitals are overlap to one another and form the bond, okay. So here the ring closing reaction was occurred, okay. Ring closing reaction was occurred. So cyclobutene is formed. What is formed? Cyclobutene is formed, okay. I have to show the orbital minus plus and minus plus. So here the bonding interaction, and we have to write like this. So you can clearly see that the 2 pi bonds are break and 1 pi bond is formed, okay, and also 1 sigma bond is formed. So this reaction is the ring closing reaction, right? So I hope you understand this concept. Now we'll take the second example. Just a minute. So already 14 minutes are gone. So now we'll take the second example. Opposite is all ring opening reaction is also take place. Okay. Let us take the example of cyclobutane. So in cyclobutane, we'll take again heating condition. So in the heating condition, what will occur? What is happen? the ring opening reaction was occur. Okay, ring opening reaction was occur. This pi bond shift to this sigma bond shift to here, and this sigma bond shift to this sigma bond. Just a minute. This sigma bond shift to here, and this sigma bond shift to here. Okay. Basically, this curved arrow indicate the movement of electron. That's why this reaction is called the electrocyclic reaction. So here the cyclobutene is again formed. So this is the ring opening reaction. Again, this is 4 and pi electron system. Okay. Now we'll take the another example with stereochemistry, so you will better understand the concept. Okay. So here we take the example of how many pi bonds are present? 1, 2, 3, 4, 5, 6. So there are 6 pi electron is present. Okay. So now we'll take two different conditions. Okay. In heating condition, we'll see what product is formed, and in photochemical condition, we'll see the what product is formed. Okay. So let us understand. So first of all, we'll take the heating condition. So in the heating condition, first of all, I draw the p orbital at the end of the carbon. Okay, so I'll first numbering 1, 2, 3. First number the each and every carbon. Okay, so here the p orbital. Okay, so 6 pi electron system means there are 6 wave functions which are possible for the cyclohexatriene. This is cyclohexatriene. Okay, so sign 3 is homo. Sign 3 is homo. So I would say earlier the odd function which has a same sign at the end of the carbon. Okay, so you just combine the same sign. Okay, how to combine? In table also we'll discuss the 6 pi electron system in heating condition. In heating condition, the rotation is this rotation. Okay, what is this rotation? This rotation means one p orbital go into the clockwise direction and second p orbital go into the anti-clockwise direction. Okay, you just have to remember this thing. Okay, so this methyl group go upward. Why upward? Because this methyl group, this p orbital go clockwise. Okay, clockwise. And in order to combine these two positive signs, this methyl group is also go upward. Okay, also go upward. So this is anti-clockwise direction. Anti-clockwise direction. Okay, so stereochemistry remain the same because both the methyl group go upward. Okay, so you write like this. This pi electron goes here, this pi electron goes here, and this pi electron goes here. So here the cyclohexadiene is formed. What is formed? Cyclohexadiene is formed. This pi bond come to here, and this pi bond come to here. Okay, and the sigma bond is formed between 1 and 6 carbon. And what about the stereochemistry of these two methyl group? Because here the chiral center is formed. Okay, because this carbon having 4 different groups and this carbon also having 4 different groups. So you have to write the chemical aspect of this product. Okay, so both the methyl group go upward means this 2 methyl group is in a cis manner. So here the cis product is formed. So this is very important for the example. You have to understand in photochemical condition which system give which product and which system undergo in a particular condition, either undergo by clockwise direction or either undergo by anti-clockwise direction. So this is very, very important. So wait, just a minute, the video is filming. So we'll go forward. Okay. I hope you understand this concept. Now we'll take the second example. This time we'll take the same system. Okay, I can write like in particular manner, so you should understand. You understand the concept. Okay, so now also we'll take the same example. Cycloheptatrine. Okay, cycloheptatrine. This is cycloheptatrine. Cyclohexatrine. Okay. In the previous case, we use the heating condition. In this case, we use a photochemical condition. Okay. So in the photochemical condition, the Psi4 is the HOMO. Psi4 is the HOMO. Okay. So how to write? I already previously I said that the even wave function having different signs at the end of the carbon. So 1 and 6 is the end carbon. So both this carbon having different signs of the p orbital, right? So in photochemical condition, what the system? This is 6 pi electron system. Okay. So in photochemical condition, 6 pi electron system undergo conrotation. Conrotation. What is conrotatory? Conrotatory means in the same direction. Same direction. Either in clockwise or either in anti-clockwise. Okay. So this methyl go upward. This pi orbital go clockwise direction. Okay. And this pi orbital go anti-clockwise direction. So this methyl go downward and this methyl go upward. So what will happen? Here this pi bond go here and this pi bond go here. And here the sigma bond formed between 1 and 6 carbon. So basically here the cyclohexene is formed, cyclohexadiene is formed. And what about these two methyl group? One is go upward. Okay, so I can write the wedge symbol. And one methyl go downward. So I can write the dash symbol. Okay, so here the trans product is formed. Okay, and if we use the heating condition, then we get a 6 product. So that's it for the today's lecture. So in the next lecture we'll discuss some more example from previous year question. I hope you understand this concept. Please subscribe my channel, and if you have any query, then comment in the description box. Okay, so that's it.